Okay, here's attempt number 2. This is a video describing or showing basically what was done for the honor stage project. So yeah, what is the project? The project is using deep learning to distinguish between subjects who have Alzheimer's and who do not have Alzheimer's, and predicting conversions from mild cognitive impairment to Alzheimer's disease within a 3-year period. So the first task is really the main task, and the second task is more granular, and yeah. So what is the data involved? So here's a Jupyter notebook, a couple of Jupyter notebooks that were used in order to process data and create the final CSV data that would be sent, that will be inputted into the neural network alongside the MRI data. And the MRI data is also right here. This is showing 4 slices for a particular subject in this particular orientation. So yeah, this project involved a big data processing or data preparation stage, as depicted here on the CRISP-DM diagram. But basically, what was done was all the data from ADNI was downloaded. So the MRI images for about 1,000 subjects were downloaded from ADNI that were already pre-processed and registered, so they were mass aligned and center aligned, and all the transformations were performed so that all the data samples were standardized. And then using that MRI data, basically the clinical data for those subjects was in a separate location. So basically what had to be done was I had to go through every single data sample, get the subject's PT ID, and then find it in this table, and then so yeah, going from this table, get the subject's PT ID, then go to this table, get all of their relevant clinical information like their ApoE4 genotype and their ethnicity and information such as that, and then concatenate it all together to make this final thing, and where each row represents an appendage to the MRI data that would be fed that would be fed into the neural network. And yeah, so the code itself, this is the code itself. Architecture.py, this declares the actual network in the PyTorch library with all the components. So this is where all the convolutional blocks and the fully connected block is declared. Conv block, FC block. What it does is it takes in the input and this is just the architecture for the thing that takes in the input and transforms it to get a label of CN or Alzheimer's disease, or the label of SMCI or PMCI. But here's the train model this is the main script that is really of interest here. It contains the training functions. Um, yeah, the model's called Camel because it's largely based on the Cambridge architecture. And before, what can be said here? um, yeah, here's what I was talking about. Here's the MRI, where it grabs the MRI data, grabs the clinical data, and grabs the label, and puts it on the GPU, and then puts it through the model that was made from the architecture script. Yeah. And it uses transfer learning. So first it trains the network to distinguish between CN versus AD, because in theory the subjects who have mild cognitive impairment lie somewhere on the spectrum of being healthy and having Alzheimer's disease. Code in action. Let's do code in action. And actually, because I was doing this before, it's already running. So also the code does k-fold validation. It does 5-fold cross-validation, where a test set, a random subset from the entire dataset is selected to be the test set, and that's always 20% of the entire dataset. And so this is so this has done an entire fold. This is a little bug. It should say epoch 40 out of 40. And as you can see, the training loss goes down gradually, and after all the k-fold validations are done, these graphs are generated under the ROC curves, and they essentially show the performance of a binary classifier by when the discriminant threshold is varied. So because the neural network spits out a number from from 0 to 1, and you, you could say that the classification is positive when that number is above a particular threshold. And yeah, so that's that, and probably over explaining stuff here. And these are the graphs that were generated previously for these graphs are for SMCI versus PMCI. That is a more granular task, and as a result, the graphs the model doesn't perform as well as the graphs that depict here, as they do as unlike on the other task. So let's close that. Okay. And in addition, there's logs generated, which have the accuracy, sensitivity, specificity information, and this part right here is not really required to be known, but it's for the final model, the actual threshold was picked using Uden statistic, and this shows what the Uden statistic was. Yeah, so there's information for every fold, and then there's an average across 5 folds that is generated. Okay, exactly 10 minutes. So there's just a few more things really, but here's a Trello board that was used to stay on track with the project. You can take all the tasks and all the stuff that was done. This helpful add-on here shows some useful information like the amount of tasks that were done. As you can see, um, I have not used a lot of labels, so yeah, more stuff to look at there. Um, yes, what else? Yeah, that's basically it. The code's also on GitHub, but yeah, that doesn't really matter too much. Uh, yeah, so hopefully this video has been informative as to what is done in the project, and it makes your marking easier. And thank you for watching.